and this just stinks not being able to be together. So here's the plan. Next time I see you in person, we're going to take this quiz to help you, since we have this day. I have put in Canvas some multiple choice questions that we normally use to help us in our review at the end, for the actual exam, but we might as well do it now. So there are a lot of them. There are Unit 2 multiple choice questions, and there are 142 of them, but our quiz is primarily 2-7 to 2-15. So the 2-7 questions start with number 57. They're marked. So Mr. Passwaters, he's got them marked. So, and they're very redundant. So in other words, there might be 2 or 3 or 4 questions that are exactly the same. I am not assigning these. I am giving them to you. I would suggest maybe doing, especially since it's been forever since we were together, maybe doing every other one or every third one or something, starting with number 57. All I can say is that review 2-7 to 2-15 that I wrote is your best source of review, and I know we've already done it. I don't know what else to say. Do it again. Work on these if you want. All that is optional for you. You have a quiz to take. It's a bigger one, so we'll want to be ready for that next time I see you in person, which I hope is tomorrow. But what we're going to do today, because we can't afford to lose a day, what we're going to do today is start talking about our unit circle. So that is available to you in Canvas. So you can either watch and draw with me, or you can stop this, go to Canvas, get what you need, and then come back. But we're going to put together our unit circle because you will need to have this memorized. It's going to seem overwhelming at first, but it really isn't. You'll see some definite patterns developing. We are going to talk about a couple of newer ideas, maybe, and we'll just do our best. Since we're really not, we don't have the Unit 3 work in front of us, we're just doing this very basic background work right now. So, this guy is called the unit circle. I'm going to be drawing some more lines in there in a minute. But for now, this is what I've got. This is called my unit circle. And the reason it's called the unit circle is it's centered at the origin, and it has a radius of 1, which automatically means that this point right here is 1, 0. This circle has a radius of 1. So you'll see the ordered pair markings. If you're using mine, you'll see the ordered pair markings there, and that is 0, 1. This point up here, that one's 1, 0. This one's 0, 1. This one is -1, 0. And this one is 0, -1. Okay? So far, no big deal. Now, if you're looking at the unit circle that I provided, you will notice that next to this ordered pair, there are some blanks. Actually, next to all the ordered pairs, there are some blanks. So, let's talk about how we label our unit circle in terms of angles. This guy right here is 0 degrees and 0 radians. We're going to talk about radians as we go around, but there are 2 ways. We're going to label our circle in 2 different ways. We're going to label in degrees, which you're very familiar with, and we're going to label in radians, which you aren't as familiar with, but which is the way that AP Pre-Calculus will label the angles, okay? So we've got to get used to it. If we stick with degrees, when we label our unit circle, this is 0 degrees. This is the starting point. Then we're going to go up and around. So this will be 90 degrees, this will be 180 degrees. This will be 270 degrees. And then if I come all the way around, this is also 360 degrees. And that's why there's two labels there. Because this point kind of serves double duty. It's our starting point, 0, but it's also our ending point, 360. Now, if I'm going to measure in radians, then I need to understand that 2 pi radians is 360 degrees. So 1 pi radians is 180 degrees. So now I can label 0 is equal to 0, but 360 is 2 pi if I'm labeling in radians. So all the way around the circle is 2 pi radians. Now I know right now you don't know what a radian is, and that's okay. You know that we have different ways of measuring things. So I can measure weight in ounces, pounds, kilograms, right? I can measure angles in different ways. So at some point, we're going to talk about exactly what a radian is and where it came from. But right now, just know that it's another unit of angle measurement. And pi radians is the same as 180 degrees. So if I come over here, notice if you're using my unit circle, there's two labels over there. One of them is for degrees, and the other one is for radians. This would be pi radians. So when someone says to you, where is pi radians, you'll say, right there. Now, what do you think this one is in radians? It's 90 degrees, which would be half of 180. So it's half of pi. So this is pi over 2. Some people say 1/2 pi. I usually say pi over 2. And then how about 270? Well, 270 is a whole pi and then another half. So this is 1.5 pi, or more commonly known as 3 pi over 2. So if you're looking at your unit circle, and you don't have to be, there are 2 blanks at every point because we have a degree measure for that angle and we have a radian measure for that angle. Okay, so what are the coordinates of the point at pi radians? Well, at pi radians, the coordinates of the point are -1 and 0. Okay? All right. Now, I have gone ahead and drawn in, I've split the quadrants and made more angles. So now I need to figure out the coordinates of that point and the coordinates of this angle. Now I think you'll have no problem with that because if I have split quadrant 1, then these angles are 45s. So this is a 45-degree angle. So in terms of degrees, it's 45 degrees. Now what would that be in radians? Think about that for a minute. Straight up is half a pi. If I split that, then this would be pi over 4, which makes perfectly good sense because pi is 180 divided by 4 is 45. So it's a fourth of a pi. What would this one be? What would this one be? Well, it's a half and another fourth, so wouldn't this one be 3 pi over 4? Or 135 degrees? I'm going to give you a minute to digest that. It's 45 degrees past 90, so it's 135 degrees. It's also halfway between 2/4 and 4/4. So it's 3/4. How about this one 225 degrees, 5 pi over 4 in radians. And finally, this one. This one would be 45 past 270, so it's 315 degrees. This is 6/4. This is 8/4, so this is 7/4. 1 and 3/4. So 1/4, 3/4, 5/4, 7/4. Now I need to figure out the coordinates of the point on the circle. So I need to figure out the coordinates of this point. Now, the ones on the axis were easy. I mean, straight up one, straight left one. Those were easy. Here I'm kind of sticking out here in the middle. So I'd like you to go back to geometry for a second. And I'd like you to remember your 45, 45, 90 triangle. This picture is going to get so cluttered. I'm not going to drop a perpendicular here, but if I did, if I dropped a perpendicular and made this right triangle, do you see how it would be 45, 45, 90? If I dropped a perpendicular, that's a 45-degree angle right there. In a 45, 45, 90 triangle, the sides are in this ratio, 1, 1, 2. You were supposed to memorize that back in geometry. Now, that would be great, except my circle is a unit circle, so my hypotenuse, my radius, must be 1. So I have to divide all of these by root 2 so that my radius is 1. So I know the ratio is 1, 1, root 2, but I need to know the sides that will make a 1 on the hypotenuse. So it looks like my x is 1 over root 2, and my y is also 1 over root 2. I usually rationalize those as just habit, so I'll write root 2 over 2, root 2 over 2. If I rationalize those. So the coordinates of the point on my unit circle at a pi over 4 radian angle, root 2 over 2, root 2 over 2. Okay, now this is what I meant by it not being as overwhelming as it first seems. When I come over here to this quadrant, if I dropped a perpendicular, this would also be a 45. These are all 45s, okay? So this would also be a 45. So wouldn't the sides of that triangle, wouldn't the x and the y of that triangle be in the same ratio as over here? Yep. The only difference is what? I am in a different quadrant. So this, instead of being positive root 2 over 2, positive root 2 over 2, in quadrant 2, the x part needs to be negative. As long as the angle is a pi over 4, some version of pi over 4, which is 45, the sides are going to be in that ratio. X is going to be root 2 over 2, y is going to be root 2 over 2. We just have to pay attention to which quadrant we're in. So down here, this is another pi over 4 angle, but it's 5 pi over 4, so it's in quadrant 3, which means x and y are both negative. Every pi over 4 is going to have the same coordinates, root 2 over 2, root 2 over 2. You'll change the SIGNs depending on the quadrant. So over here, it's another pi over 4, 7 pi over 4. So that's going to be root 2 over 2, negative root 2 over 2. Okay. is 30 degrees. How many radians is 30 degrees? Well, remember, pi radians is 180. Since 30 is a sixth of 180, this is pi over 6. 180 divided by 6. Pi divided by 6. That is 30 degrees, pi over 6 radians. This guy right here is the 30-degree angle in quadrant 2. So he would be, what, in terms of degrees, he would be 150. Okay, make sure that makes sense to you. This is 180. This is 30. 180 is always my 180 or 360. The x-axis is always my key. So this is 180. I stopped 30 short, so that would be 150. How many radians is 150? Well, let's be smart about this. 180 is a whole pi. 30 is pi over 6. So if I have a whole pi minus a sixth, don't I have 5 pi over 6? Pi minus, or 1 pi minus 1/6 pi. And then similarly, this is my 30 in quadrant 3, so it's 180 plus 30, so it's 210. It would be pi plus a sixth, which is 7 pi over 6. So we have our degree measure and our radian measure. And how about quadrant 4? This is your guideline right here, 360. So in degrees, this would be 330. What would it be in radians? This is a 30 right here. So that's why this is 330. You're measuring from the horizontal, always from the horizontal. So that's 330 degrees. All the way around is 2 pi, which is 12 sixths. If I skip this, I'm at 11 pi over 6. Let that sink in. And when you get confused, always go back to pi is 180. Pi is 180. So you're going to either take pi plus or pi minus, whatever you're doing, or you're going to take 2 pi, which is 360, minus, take this one, 0 plus. All right, now I need the ordered pair, the coordinates of the point, the x and the y on the circle. So what I have marked inside the circle are my angles. Outside the circle, I am marking the actual ordered pairs of those points. Okay, so this is a 30-degree angle. So again, I'm going to come back to my geometry, and I'm going to remember in a 30, 60, 90 triangle, across from the 30 is 1. Hypotenuse is 2, other side's 3, longer is 3. So hopefully you remember that. If you don't, here it is. There it is. That's what you're supposed to remember. Now that would be perfect. X is root 3, y is 1. That would be perfect, except I need my radius to be 1. I am in the unit circle. I need my radius to be 1. So I can divide all these by 2. So now I can see that if my angle is 30 or pi over 6. X is root 3 over 2, and y is a half. X, y, horizontal, vertical, x, y. For a 30-degree angle, x is root 3 over 2, y is 1/2. And that is true for every 30-degree angle. So when I come over here to quadrant 2, and I have my 30-degree angle in quadrant 2, I'm going to have negative root 3 over 2, positive 1/2. And then in my quadrant 3, negative root 3 over 2, negative 1/2. And finally, quadrant 4, positive root 3 over 2, negative 1/2. All right, we're almost done. We're going to do one more. You can guess what it is. We've done our 30, we've done our 45. Now we're going to do our 60. So I really don't want to clutter up my picture too much, but now this is a 60-degree angle. So this is 60 degrees. Okay? So the angle I make with the horizontal is 60 now, 60 degrees, which is how many radians? If pi is 180, then what? Pi over 3? Okay. And then this one, now be careful. Remember, you're making the 60 with the horizontal. So this is 180, I'm backing up 60, so this is going to be 120 degrees, which is how many radians? Well, a couple ways you can think about it. If 60 is 1/3, then wouldn't 120 be 2 60s, so 2/3 pi radians? Or you can remember that this is always your reference. So this is 3/3, back up 1/3, put you at 2/3, however you want to remember that. How about this one? Well, now I'm going 60 past 180, so this is 240. And 3/3 and another third, this is 4/3. And then finally over here, remember, measure with the horizontal. So this is 60. So this would have to be 300. 5 pi over 3. 5 60s. 5 times pi over 3. Okay, now I gotta figure out what those points are. So I'm gonna come over here to my 60-degree angle. Now the sides are in the same ratio as they were for the 30. So across from the 60 is root 3, across from the 30 is 1. There you go. We have the same issue. We need the hypotenuse or the radius to be 1. So I divide everything. And now I see that for my 60, or pi over 3 points, x is 1/2 and y is root 3 over 2. So x is 1/2 and y is root 3 over 2. Horizontal, vertical. And then for every pink, every 60, every pi over 3 angle, I'm going to have the same x and y. I just have to adjust the signs. The SIGNs. And there, my friends, is your unit circle. Remember, on the AP Pre-Calculus exam, there's no reference sheet of any kind. There are no formulas given, there's nothing. You are totally on your own. So it's imperative that you know how to create this circle. I don't really ever draw the whole circle. I generally draw just quadrant 1 because I know that everything else is going to be the same except for the positives and negatives, right? So I need to figure out, I need to know these points right here. I need to know those. But then I know that every 30 will have this ordered pair, every 45 will have this ordered pair, every 60 will have this ordered pair, with some changes with positives and negatives. Alright? So I'm going to show you how that works here. I'm kind of getting a little bit out of order on stuff, but I don't know what else to do today. So, let me show you, let me tell you one more important piece of information, and then I'm going to show you how to do a couple of problems with all this. If you don't quite have all this down yet, you can just rewind after a bit and get it, because I'm going to have to erase it. But before I erase it, if I am in the unit circle, if I am in the unit circle, then the cosine of theta, the cosine of an angle, is the x-coordinate, and the sine of the angle is the y-coordinate, if I am in the unit circle, which I always am. This is our Bible right here. We don't go anywhere without our unit circle, or at least part of it. So, as long as I know these ordered pairs, I can find the sine and cosine of any of my special angles. You learned in geometry that 30, 60, 90, 45, 45, 90 were special triangles. Well, those angles are called the special angles. And I can find the sine and cosine of any of them as long as I know which quadrant I'm in. Okay? This is a big deal. So let's see how this works. We'll do a couple. And then I will let you go. When we get to this in the notes, we'll probably just skip through it pretty quickly. I really want you to start getting comfortable with your unit circle to save time later on. Okay, so let's say for some reason I need to know the cosine of 2 pi over 3. Now, it's a pi over 3 angle. Look at your unit circle. It's a pi over 3 angle. Those are the 60s, right? So when I look at my first quadrant of my unit circle, this is what I'm looking at. I've got my pi over 6, my pi over 4, my pi over 3. That's the way it looks in quadrant 1. And then over here would be 2 pi over 3, 3 pi over 4, 5 pi over 6, and so on and so on and so on. Okay, this is day 1. We'll make one step at a time, right? So 2 pi over 3. I know that in quadrant 1, for pi over 4, they're both root 2 over 2. I never have any issues with that. They're both 1 over root 2 or root 2 over 2. Easy. Pi over 6 and pi over 3. They have the same numbers, they're just flipped. So remember, if you're pi over 6, you're going over farther than you're going up. So root 3 over 2, 1/2. cosine is the x coordinate. So I need to know what the x coordinate of the pi over 3 angle is in quadrant 2. That's 2/3. Here's 3/3, 4/3, 5/3, 6/3. Put your unit circle. And again, this is day 1. Get used to how it works. So 2 pi over 3, I know, has the same coordinates as pi over 3. Every pi over 3 has these coordinates. 2/3 is in quadrant 2. In quadrant 2, the coordinates are negative positive. So it'll be negative 1/2, positive root 3 over 2. Cosine is x. X is negative 1/2. Cosine of 2 pi over 3 is negative 1/2. Now, I totally get, because we're doing things the way we're doing them, because we're never in school to see each other, I get that you don't even know what cosine is, you know what radian is, and all that. Just take it one day at a time, one day at a time. We're going to start by finding sines and cosines. We know that cosine is x on my unit circle, and sine is y on my unit circle. So let's try another one. Let's do the sine of 7 pi over 6. Now that is a pi over 6 angle. Every pi over 6 is going to have these coordinates, you guys. Every pi over 6 is going to have these coordinates. Your job is to figure out which quadrant is that in. Well, you can look at your unit circle, or you can use your head and remember that halfway around is pi. And this is 1.5 pi. And that is 1/6. So isn't 1/6 right here in quadrant 3? In quadrant 3, you know that the coordinates are negative, negative. So the coordinates for that point would be negative root 3 over 2, negative 1/2. We want the sine. Sine is y, so it is also negative 1/2. We're not going to be alarmed when we get duplicate answers, because look at the numbers on the unit circle. Aren't they just all repeating? Yeah, you're going to get the same numbers over and over again. All right, let's try a couple more. Let's try cosine pi. This one's a little bit different. What about pi? Pi isn't any of these. No, pi is right here, isn't it, on my unit circle? And what are the coordinates at that point? Pi is not 1/3, 1/6, or 1/4. Pi is pi. And pi is on an axis. It's right here. And the coordinates at that point are negative 1, 0. So the cosine of pi is x, and x is negative 1. I'll do one more together, and then I'll give you a couple of minutes by yourself. Let's do another sine. Let's do sine 5 pi over 3. So I know that a pi over 3 angle has these coordinates. Period. There's 3 of them. I can't remember what color they were on my unit circle. There's 4. Can't remember what color they were on my unit circle, but you've got pi over 3, 2 pi over 3, 4 pi over 3, and 5 pi over 3. All of those have they have these 2 coordinates, sometimes positive, sometimes negative. So where is 5 pi over 3? Well, 5 pi over 3 is like 1 2/3. So it's bigger than a half, less than 2. So it's in quadrant 4. In quadrant 4, your coordinates are positive, negative. This angle is in quadrant 4. I really want you to get used to thinking of it in radians, but if you're really struggling with that, remember pi is 180. A third of pi is 60 times 5 is 300. This is 300 degree angle. So 0, 90, 180, 270, 300 is right over here. AP Precal is in radians though, so it's really going to help you if you remember in radians. So 5 pi over 3, down here in quadrant 4, we want the sign. The sign is negative root 3 over 2. Sign is y. In quadrant 4, y is negative. Okay, I'm going to erase everything now. And I'm going to give you 3 to do. And then we'll check them and then we'll be done. Okay, so let's have you do the cosine of pi over 4, the sine of 3 pi over 2, and the sine of 4 pi over 3. All right, so why don't you take a second to work on those, and then we will do them together and see what you come up with. Okay, which quadrant is this angle? It's a pi over 4 angle. Pi over 4 is the easy one. Sine, cosine are both root 2 over 2. X and y are both root 2 over 2. Which quadrant is 3/4 of a pi? Well, remember that a whole pi is over here. So I hope you put this in quadrant 2. And if it's in quadrant 2, the coordinates are negative, positive for a pi over 4 angle. And we want cosine, so the answer is the x coordinate, negative root 2 over 2. Did you get that right? Okay. 3 pi over 2. Whoa, that's a different one. That is not a pi over straight down. 3 pi over 2 is 270. This is 0. 90, 180, 270. Straight down. What are the coordinates? Straight down. 0, -1. We want the sign, so the sign is y, which is -1. When you did sines and cosines before, you probably used SOHCAHTOA, and that's great. We were doing right triangle trigonometry, that was absolutely magnificent. Now we're doing circular trigonometry, so our values are coming from not opposite hypotenuse, but they're coming straight off the unit circle. Okay, 4 pi over 3. All right, so we got a pi over 3 angle, so I know I'm going to have some combination. Pi over 3, 1/2 root 3 over 2. Where is 4 pi over 3? Which quadrant is 4 pi over 3 in? Well, remember, that is a whole pi and then a third more, 1 1/3. So 4/3 is down here in quadrant 3. This is 1 1/2. 1 1/3 is less than 1 1/2. It's more than 1, less than 1 1/2. It's right down here in quadrant 3. So 4 pi over 3 will be negative, negative. I want the sign. The sign then is the y, or negative root 3 over 2. Okay? I have one more piece of information to give you, and then I will shut up for today. On the unit circle, sine is y, cosine is x, tangent is y over x. So we're going to do everything exactly as we've been doing. We'll have our ordered pairs for our special angles. We'll just put y over x. So, for example, if I want the tangent of 3 pi over 4, first thing I have to do is figure out where is 3 pi over 4. Well, 3 pi over 4, I hope you know, is going to be in quadrant 2. Over here. And it's a pi over 4 angle. So I know my coordinates are root 2 over 2, root 2 over 2. But since I'm in quadrant 2, more than a half, less than a whole, is in quadrant 2. I know my x is negative. So what happens when I put y over x? Don't get confused. They're the same, aren't they? So when I put this one over this one, I'm going to get 1. But since one of them is negative, I'm going to get -1. So the tangent of 3 pi over 4 is -1. -1 is y over x at a pi over 4 angle in quadrant 2. All right, how about this one? Tangent 7 pi over 6. Well, it's a pi over 6 angle, so I know my ordered pair is going to be root 3 over 2, comma 1/2. That's my pi over 6 ordered pair. Now I need to figure out which quadrant I'm in. So 7/6 is 1 1/6. So won't this be in quadrant 3? 1 1/6. 6 more. In quadrant 3, they're both negative. I have to put y over x, so negative 1/2 over negative root 3 over 2. Well, first of all, the negatives are going to cancel. And second of all, the 2's are going to cancel. Now, if that confuses you, remember, this is 1/2 divided by root 3 over 2, which is 1/2 times 2 over root 3. See how those 2's are going to cancel? If they're both in the denominator, they're going to cancel. And that leaves me with 1 over root 3, or root 3 over 3. Both of those answers are acceptable. We just need to make sure we're following whatever directions have been provided in terms of rationalizing. Okay, one more. Let's try the tangent of 3 pi over 2. All right, this is now pi over 3, pi over 4, pi over 6 angle. 3 pi over 2 is on an axis, it's right down here. So the coordinates of the point, remember, that's what I need. I need the coordinates of the point on the circle. So at 3 pi over 2, this is my point, straight down 1, 0, negative 1. Right? I want tangent. Tangent is y over x. So negative 1. Undefined. When we graph a tangent, we are going to have asymptotes, vertical asymptotes, because there are places where the tangent cannot exist. And one of those places is right down here at 270. All right, guys, one more time. Next time I see you in person, we're going to have our big quiz. It will take the entire period. It won't take you the entire period, most of you, but we'll take the entire period for the quiz. To help you review, I've uploaded whichever way I loaded, those multiple choice review questions. Your focus should be on 57 and beyond, but of course you're invited to do all of them. But again, don't feel like you need to do all of them from 57 on, because he's got, in every question, there's 2 or 3 that are exactly the same. So maybe if you struggle with 57, do 58, but if you got 57, skip it and go on to 59 or something. And that review sheet that I wrote is your best review. All right, have a great day.